Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on Twitch. Today I'm hoping that we can do something kind of fun with our debug system, because we had to do a bunch of work. We were making something to analyze the running of our program, and we kind of did something that I think is pretty cool. We're actually now tracking a heck of a lot of information about the running of the program. And we sort of, on Friday, just did the work to kind of start collating it, but we haven't had a chance to really see what that data actually says, because we only just got the basics of collation in, and we essentially collect a ton of information, but don't have much in the way of any kind of visualization to see what it all means. And so I'm kind of looking forward to this week, because I think this, we kind of had to do a bunch of work under the hood to make it, all of the actual data get collected properly. And so now I think this will be kind of a more fun part where we get to start seeing a little bit more about how our program is working and kind of get the payoffs of having done that work, if you will. I'm going to go ahead and get started. If you want to follow along, today is day 185. And so if you want to follow along, day 184's source code is the source code that you want to unpack if you are someone who has pre-ordered the game on handmadehero.org. So taking a look at where we left off, we had just we typed in some collation code, but I don't think we'd ever actually run it or check to see if it was at all valid. I don't actually remember, to be honest with you. I do not remember what we did on Friday. I don't even know if we ran it. Maybe we ran it. Yeah, so it looks like we have not actually ran it yet. We would have assuredly saw that. It looks like our current frame is 0 here. And so, yeah, obviously, this bit where we actually get a new frame for collation, we have not actually done the work to actually have anything in that frame. So frames is 0. So whenever we get a new frame from there, it's going to be garbage, and then we're going to write to it, which is going to crash. So at this point, we just want to kind of, again, no mystery here. We just want to go in and just finish the code. Like I said, we had started it. It's not done yet. And so we kind of want to finish up the code, which is easier said than done, because, of course, I don't remember what we were doing. It's been a while. Had a lot of work to do over the weekend, and then work to do today, and so it's been, it's been paged out. But here is our debug frames, and if you remember, what we decided to do is we have essentially a debug scratch pad, a bunch of memory we can just use to do whatever we want in. And it just gets thrown away every frame. So we can just do whatever we want, hit party on it, and then it just gets reset, basically. So when we're in there, when we initialize everything, right, at the beginning right here, we begin the temporary memory, and then we call collate debug records. Collate debug records has the ability to basically use that memory however it wants. And you can see it sets frame count to 0, but what it doesn't do is actually initialize frames in any actual way. And so what we want to do there is we can just go ahead and say, let's get some frames, or fangs, as the case may be. Those are always good. Those are, of course, a very close relative of the frame, a fang. So what we can do here is just do a push array. Since we have that collation arena, we can do whatever we want with it. So if I want to push an array on here, I can say that however many frames we are going to have, and of course we know how many we're going to have, right, because we have a certain a bit of storage for that. Of course, for some reason, I don't actually see it being used here at all, which is a bit odd. So that's a bit weird. But I guess, do we ever even define it? I guess we wouldn't have to have, but let's take a look. So we do have max debug frame count here, so we can go ahead and use that as well, like so. Although the other thing that we could do is, since we're using a scratch pad, we could do something like daisy chain the frames together. And if we daisy chain the frames together, then we actually wouldn't have to do anything like that. We wouldn't have to we wouldn't have to do anything where we we wouldn't have to do anything where we guessed how many. It would just be how much memory we have. Now, it occurs to me, though, that because max debug frame count is being used here in the event count, the interesting thing about it is that assumes that we only issue one frame end event every time, because otherwise, yeah, the event counts, we wouldn't be able to hold enough event arrays to actually count any more frames than that. But technically inside the frames, we could actually have tons of those frame end events if we wanted to. So it's kind of weird, like max debug frame count is not really probably the best word for that. It's really event array count, and technically those things are not really coupled. Like, you don't have to have those two things be related. It's a little bit weird, right? It's hard to say, but you know, it's just a little odd. So technically, you know, we could say, well, you know, it's technically, let's say that it's something like we can't have any more than 2 or 4 of those per frame, or who knows what. And technically, we should only have the same number as those, but there isn't anything preventing the code from outputting multiple frame end events inside a single event array, which would lead to more frames than event arrays, if that makes sense. Hopefully it makes some sense. So anyway, what we want to do is, again, just allocate some debug frames here. So let me go ahead and do that. That allocates just an array for storing those guys. Again, max debug frame count here. Not what we want. We want event array count like so. And as we kind of go through, like I said, current frame is getting used every time we see one of those frame markers, we advance it to a new pointer. And when we do that, now we're going to actually have valid memory for it. But when we have that valid memory, again, if you look here, we've got these debug frame regions, which are something that we're going to want to start writing into. And so we need some way of actually allocating enough of those regions. We want to allocate a set of those regions so we can kind of show where they are, right? And so we got to start thinking about how we're going to do that. And in order to have some memory for that, we're also going to probably want, right, to allocate space in that current frame for the region. So we'd have current frame regions, and in there we would say something like push array. We could also actually, again, do it where we didn't do push array like that, but we could, for now I'm going to go ahead and just do it that way, where we then say, I don't know how much we allocate into a frame. Let's see here, probably something like, I don't know if max debug event count is probably a little too large, so I'll do it on the order of this for now. But again, these are kind of just arbitrary. And we may want to switch to a thing where we just use the memory that we need as we go, rather than kind of doing these array-based ones, because I don't know that we actually need arrays for any particular reason. So I'm going to do it like this for now, but I think we may want to do it a little bit more conservatively, just because we don't really know much about what's going on here. And so maybe just daisy chaining them together would be the smarter way to go. So yeah, if we go ahead and put these regions in here, now we have a place to store the regions, and I can compile this, and that's probably fine, and I could probably run it. Okay, so we do, like I said, we do run out of space there. Part of that, I don't know how much memory we actually reserve for debugging, probably not as much as we might want. Let me take a look here. Yeah, so debug storage size is actually quite small, as the case may be. So in terms of just storing these massive numbers of events or something like that, it's not going to be able to do it. So I don't know exactly, again, what we want to do there, but probably something... for now, I might actually say that let's just do something kind of tiny, just for a temporary thing. Let me see how much we can do. So we can't really do very much at all with that size of arena. I'm going to go ahead and do that. What is it complaining about there? Current frame region count. Looks like I did not allocate this properly. Is that correct? We've got our debug frames. How many frames do we have? Let's see here. Frame count. Oh my. So we're doing something a little bit odd here. It looks like we've got some kind of a bug, because there should not nearly be that many frames, right? So it looks like we've done something bad. Let's see. What's our event array index? Is 3. Our valid event is 1. So it doesn't feel like we should have gotten up that high. It's a bit odd. I'm gonna take just a quick gander here at what's going on. I don't like the looks of that at all. So as we roll through these events here we are adding one in. How are there that many of these? This is bizarre. Ah, that's the problem. this is totally bogus. We need to actually only loop through the event indices that are actually there. So that's just wrong, right? We actually need to do this so that we can loop over the amount of events that are actually present. So that's just a bug. And so now we should be in a much better position to see about the memory usage. All right. Okay, so now we're at least in reasonable running shape. So let's continue on with doing some of this collation, because I want to work out how we actually have to collate this stuff, since it's a little bit tricky, I think. So let's take a look. So what's going to happen here is we've got these debug events, and the debug events themselves, we don't even really know how much time a particular debug event takes, right? Because we don't have any idea when it actually ends. So when we see a debug event, we see like its begin block. We don't know when we're going to see the end block, right? So we have kind of a nasty problem where we have to start pairing these things up together. And we do have the debug record index, which is something that allows us to figure that out. But we need some way of actually creating like a collation space where this can happen. So we know that any given debug record index, we can have, I'm going to go ahead and draw this out here. For any given debug record index, looks like we zoomed out. See, that's more what it typically looks like now. All right. So this is fairly complicated, right? Day 185. So the way that this would work is we've got a set of functions. We've got a set of blocks in the code. And each block, I don't know, we've got some code in here, right? And each block is going to have that begin and that end point. But we don't know very much about the circumstances under which one of these could be called. So for example, if this is in some kind of a function, right? So this is in some function called foo. In fact, let me just go ahead and actually write it here. So let's suppose we have a function called foo. And in that function, it calls itself recursively. So even just in this simple scenario, we know that in a single invocation of foo, we may end up re-invoking foo itself, and thereby opening one of these begin blocks multiple times before we ever see an end block. And so what that's going to write out in the log is it's going to write out something like, begin foo, and let's say it just goes too deep. So then it goes end foo, end foo. So that is how this would look, and these are paired thusly. We would see begin foo, and then we would see begin foo again. We would know that we can't begin foo a second time if we've already begun it once without seeing an end, unless it's a sub-invocation. So we would know that somewhere down the line foo called itself, either directly or indirectly, right? Now this is true only insofar as the thread index is the same. Because at the same time on a separate thread, somebody might have called begin foo here, might have called through, and maybe had a begin and an end pair. And so what we could see is something like this. I'm going to put thread numbers here. So the thread ID is here, and this is the event. So the thread ID on thread 0 might do begin foo. The thread ID on thread 1 might then do a begin foo. Then the thread ID 0 might do an end foo. Then thread ID 1 might do another begin foo. And then thread ID 1 might do an end foo. And then thread ID 1 does another end foo. Now the naive parse of this, right, is that it would look like this begin and this begin look like this. This one pairs to that, and this one pairs to that, right? That's what it would look like. But it's not true because there's two different threads in play. So they can only pair if they're on the same thread, because obviously if they're on two different threads, then the beginning and the end don't match. So we only look at 0, right? And we say, oh, okay, there's a pairing there. Then we only look at 1 and we say, oh, okay, there's the pairing there and there's the pairing there. That's the actual operations that we need to do. And that would tell us how these things are grouped up. So in order to do that, as we're reading through these things, right, as we kind of read through them, for every one that we get of these guys, we need to kind of say, all right, so we have the location, right, because that is the counter index. We know the counter index. We have a way to index it off of, it's got a unique ID, right? So we have the unique ID, and that plus the thread ID gives us essentially a completely unique ID. And then the same is true for the end. So we're really looking for the thread ID plus the counter ID, right? And I shouldn't say plus. It's more like appended to, right? It's almost like the thread ID dot the counter ID, you know, as like a grouped number. What we're doing is we're looking for paired versions of that. And so I don't know the best way to do this. I'm going to do it as a simple stack for now because I feel like the number of these that can be open at a time is not that high. And so I feel like doing a giant open like addressing kind of a scheme where I have like some giant thing which is like thread IDs this way, CIDs this way, and each one of these guys is some linked list of open things that get closed off or something. I think I'd rather avoid doing that entirely. I don't think that's a good use of anyone's time. Because in general, anytime you see an end, it's going to match the most recent begin on that particular channel, right? And furthermore, begin and ends kind of end up being paired most of the time, so you shouldn't have to look back very far. Most of the time, an end block pairs with the thing that was the most recently opened, you know? And so I think what I'd like to do is just per thread, so per thread ID, I will keep a linked list of what blocks are open, and I'll just search that linked list from the end back towards the beginning, if that makes sense, to see what closed, and if something closes, I'll remove it. If we wanted to special case it and say that we don't allow anything to be overlapped on the same thread, meaning we don't allow someone to go begin foo on thread 0, begin bar also on thread 0, then end foo on thread 0, end bar on thread 0. So you see how that does like this hop? It does like an interleave. It's like it begins one thing, begins another, then ends not the one that's most interior, but the exterior, like that. If we didn't allow that, then it would always match the last one, right? You never have a circumstance where the thing that gets matched isn't the very last one. So we could also make that restriction without really much of a loss of generality, but because it's not too hard probably to search through the linked list, in the rare case where that's not true, we might as well just support it because I'm not sure there's that much of a reason not to. It may ruin some kind of like stacking notion that we have. It makes it kind of hard to draw bars because the bars can overlap even on the same thread, you know? Like if you're looking at a thread and we wanted to draw like bars like we were saying, where we have thread 0 and thread 1, if we want to draw these kind of bars in there, it's kind of weird because now you might get a bar where this is the time for foo and this is the time for bar here, but actually it kind of penetrates a bit into there. So it's kind of hard to draw that too, right? Because they overlap. And so it's almost like you need as many lanes as you have open things. And that's, again, it makes it difficult visualization-wise. So it may be that there's just a good reason to say we just don't allow that and we consider that an error. And then when you're doing your block timing, you should never always use like a time block that, you know, closes in order. Because I don't know that we give up anything for that, and it does ensure that our visualization will be easier and it's easier for us to see what's going on, rather than having to try and invent some visualization that's not that doesn't obey the standard scoping rules of like C, where, you know, things get closed out in the order that they get opened and stuff like that. Okay. So let's see. So I need some storage for, I just need like, you know, open, like an open block, like an open debug block. And the open debug block would have some kind of like a pointer to the previous block, or the parent, I suppose, right? Like whoever was above me. And the information in here, I think, would be the same information roughly as would be in the debug event structure. So I would say that what we'll do is we just say, let's point to the debug event structure itself. So this is the opening event, and that is presumably all we need. And we get to the end event, we then would have the beginning and the end events, and we can then collapse them and do whatever it is that we want to do with that information, because we would have all the information that we actually need, right? Excuse me. I think that would be fine. Yeah. So then we would just have to have one of these for every thread. So we have like open block for a thread. You know, again, I don't mind having a lot of max values in here, because again, it's just for our own purposes. It's not something that ever runs on the end user's machine or anything like that. And plus, I guess we could say some ridiculous number that we will never have the luxury of having, because I don't know that Handmade Hero could really make use of 256 threads. But in the future, there will certainly be computers that can do 256 threads. I mean, you know, a Xeon Phi someday probably will do 256 threads in a couple years, I would think, potentially. Seems reasonable. Anyway, I mean, obviously you can make 256 threads on anything, but I mean 256 threads that actually are all doing work at the same time. So if I have that open block for thread, then what I should be able to do is put in, and I could probably use this for the thread ID stuff as well. So what I could probably do is say, all right, for the thread IDs, I'll also go in here to where we keep track of that. Excuse me. This is technically not a thread index, it's a thread ID. We should probably note it as such. And then I'll come in here to the debug open block, and I'll do something like say that we've got the thread ID on there. And then when we initialize these at the start of the debugging process, as they might say in Canada, I will do a open block for thread. In fact, I suppose I can actually just do it this way. You know what? I might even do it slightly differently. I might say like debug thread or something like that. And I might actually put the thread ID in here and the first open debug block in here. Like so. And then I will just say that we've got an array of debug threads, and that way I can sort of add more information in there for the collation walk as we go. I also don't know that we need this in the actual debug state itself. So what I might do too is I might say that at least for now, until I have like a real reason not to, I might put it up here as well. So I do something like we've got our debug threads here, and our debug threads is just going to do a push array, and that's going to do the thing to get us some storage for the number that there are, mass debug thread count. So if I push those on there, I can then run through them and initialize them to whatever I would like them to be. U32. And I guess the other thing to think about is when we do get lane from thread, I can kind of collapse these down. So get lane from thread. Since I iterate them in order, I guess we don't even need max debug thread now that I think about it. We could just chain these if we wanted to. It's kind of a little bit jankier, but they're all going to be relatively close to each other. Potentially, well, no, I'm torn. I'm torn a little bit. I'll leave it this way for now, but we don't really even need to do that to some degree. We could actually avoid having there be any fixed number. So maybe I'll just do it that way, and we'll see if there's any real penalty for doing it that way. But if I have a debug thread like so, and then I just do like a next on there, I can do something much more simple, which is I can just say debug thread first thread, right? And I guess that goes here. So if I did that, then we don't clear or do anything at all at the outset. And the same would have been true for frames. That's why I was saying maybe I should have just been doing that kind of policy. And so when that happens, in here what we would do is when we call into this function that's like get lane from thread index, instead of doing it that way, what I'd rather do is something more like debug thread get thread or get debug thread, something like that, so that we can get it back like this. We'd pass in, instead of the debug state, which is not what we want, we would just pass in that first thread pointer, you know? That's all we would need there. So if I pass in the first thread pointer, I assume the debug thread will get that back for me. Now when I have that thread as a thing, the lane index presumably can just be retrieved directly from there. You know what I'm saying? So on here, on the debug thread, it would just have a lane index on it. Now, there's going to be a couple different things that kind of need to be there, which is one reason why maybe on debug state we might want to put it there. But frame bar lane count actually, I guess, is the thing. So if I pass debug state into this, I suppose it can just use that and still keep it this way. I'm just trying to figure out whether I want the threads. I probably do. So I'll just go ahead and stick it here. There we go. So when it does the collation, it'll do like first thread equals 0 and just clear it out. And then from then on out, it'll use it there. We'll just leave it that way. Okay, so when I grab that thread out, I then have the ability to search to see what's going on with this guy. And so inside here, when we do our begin block and end block pairs, what I should be able to do is say, well, for the begin block, we know we're always going to create a new open block every time we see a begin block, you know? So we're always going to have, like, for every one of these, when I come through here, I've got a debug block. I'm going to do a push struct onto the debug arena, and I'm just going to push on a new one of these open guys. Although I probably will want to recycle those since we pop these guys off, but we can do that in a second. In fact, I guess I could just do it now. Again, pretty straightforward. Open debug block first, free block. So what I would do there again is when I initially do these guys here, when we sort of initialize everything at the beginning, we just set those both to 0. And that's all fine. So in here, when I do my push block, instead what I can do is just say, all right, let's set it equal to the first free block first. So we'll just set it to the debug state first free block. And then assuming that we got one, we would set debug block first free block to be our next, right? Which I suppose we would just do something like this, since we don't really care. Right, seems simple enough. And then we've got our debug block. But if we don't have one of those, then we need to make a new one. So if we don't have one of those, we just go, okay, the debug block equals the push struct, and we grab one. Open debug block. Once we have a debug block, we need to set the values to whatever it is that we're actually trying to record. And so if we take a look at where that is, we have the opening event. We know what that is. It's the event that we're on right now. So that's just the event pointer that we're processing. we know for that open debug block what its parent was, and the parent was whatever was previously on this stack, like whatever the open blocks were, whatever is on this thread stack. So since we have the thread, we would just say whatever the first open block is, that's the person who must have called us, because that's the last thing that was opened before we got hit. And then finally, we know that now we are that new block. So we're kind of just daisy chaining these guys together, right? And that's all there is on there. We can also set the next free equal to 0, although that doesn't really matter because no one's going to be looking at that pointer. But we can set it that way just for fun. So that's all that would happen there. When we end a block, we're going to do the opposite set of events. So what we want to do here is we want to go ahead and pull off the matching block for this block. Now, in order to do that, we have to figure out what block actually is matching ours, which should be the last one on our thread. And so what we could do, again, is we could assert that they match and not actually ever do any other processing. But we could also write something that searches for them. And so I'm going to write the thing that asserts for now so we can see if we have any of those. But it would be fairly easy to just search through the list and find the one that matches either way. So we hit the end block. We come through here. And I suppose, the other thing too is there might not be an end block. It might just be an open block, now that I think about it, because it may be that the open block happened many frames ago, and those frames have fallen out of the event array, So it's possible that we just don't have one. And so the other thing we could do is we could just say that, like, at that point, it's just an indeterminately open block. So maybe I'll do that. We'll just see. So first of all, I'll say, assuming that the thread has an open block, then we'll say, all right, if the thread's first open block, opening event, if that matches, and in order to match, it needs to have a couple things be true. First of all, it would need the thread ID to match our thread ID. Oops. Then it would need, and you know what? I'm gonna pull this out into a closing event, just so I don't have to keep. Into opening event, so I don't have to keep doing that giant dereference. It's just a lot of typing, like so. So we have the thread ID, we have the debug record index, and then finally we have the translation unit. If all of those things are the same, then we know that these two events match. If they don't, we know that this event ended, but there was no beginning to it. And how we choose to record that is going to be up to us. Probably what we'd want to do is put in a bar that kind of stretches back to the beginning of time, at the beginning of the chart. But we're not really quite up to that point yet in terms of even having a handle on the visualization. But so assuming that we get a match, we now know that these two events close, right? These two events line up with each other. And so what I'd like to know, I suppose, is what what frame we were actually on when we did our begin. Because if the frame that we're beginning on was not the frame that we were ending on, then we kind of have some work to do in terms of recording how this actually went down. And so I feel like in here we probably want some way of saying, not there, in here, we want some way of saying for the open event, what was the frame index? So that in here, when we're looking through, in fact, I'll go ahead and say we have a frame index like so. And looking through, we've got the frame count stuff and all of that. So as that happens, I guess we don't really need frame index because it's actually specified right here to some degree. Whatever that frame count is, that's the thing. So we could just do it. Like this and record that frame count. It's really the frame count -1 is the only thing. But, you know, that's certainly something we could do if we wanted to. So if that's the frame index, then while we're in here, we can just say whatever the opening event is when we do this open debug block. We can say that we know that the frame index, or this starting frame index, is equal to whatever the frame index was at that time. And so here we could do a test to see. So we could say if the debug block starting frame index equals whatever frame index we're on, then we would do sort of the standard span. Otherwise, we would have to do something where we do 2 halves of a span on the starting and ending frames and full spans all the way in between. So again, that's going to require a little bit more work on our part in terms of recording. In fact, I'll just kind of say record span that goes to the beginning of the frame series. This is record all frames in between and begin end spans. And then this is the standard case. This is the case for most of our stuff where we're just inside one frame, we're putting in one of those bars. And so here what we can do is we can actually add a debug region, which is what we're actually drawing. And so if we wanted to draw this debug region, we would say, add region. I don't actually know how we would do that exactly, but debug state and current frame. It's where we're trying to add it. So when we add one of these in, we can then specify this stuff. So the lane index we know is whatever the lane index of the thread that we're on, because all of the things in this thread go into that lane. We know, in addition to the lane index, the min and max t are just us sort of mapping the begin and end clocks, which we now know, mapping those into the total time region for this particular frame. And how we map those in, I don't remember if this is 0 to 1. I don't remember how we did the drawing. I suppose we could take a look at how that was done, perhaps separately. Ooh, tired, Casey. I don't have a lot of energy. It's true. It's because I overate. I overate yesterday. There was a lot of food consumed. Just not really the right amount of food for a single Casey to be eating. So inside the debug code, where we draw this, how did we choose to do it? We do scale, and scale is whatever the frame bar scale actually is. So I guess we don't know. It's entirely up to us what we wish to do. So I suppose the way to do that is just allow our t values to kind of be crazy RDTSC based stuff. That seems like probably what we would want to do. I don't know if we want to store R64s as a result, but we can think about that a little bit separately. But in terms of these here, then for min t, max t, then so on, what I can do there is say, all right, the opening event and then the closing event, which is us. We know where those are in time because we have the clock value, the U64 clock value. And so if I cast that to an R64 so I can do some operations on it, right? I could then choose to sort of regularize that a little bit. Like, for example, you know what I could do? I could use a floating point value to store it. And this is kind of inaccurate. Again, I don't know if I love this. But we have that relative clock concept, which is just whatever the start of the frame was. So we know that we could take that out, and now we have like a much smaller number to deal with. We know that it would this number would only be roughly on the order of a couple 100,000. I'm sorry, a couple 100 million, right? And so that's not too bad to represent potentially in an R32. Yeah. But again, we might want to do a little bit more, something a little bit nicer there. I'm not sure. Okay, so if we do that, we now have the ability to sort of categorize things in the lanes properly, and now we know like roughly where they are as well. We could also do something where we don't, if the total size of something is not large enough, we wouldn't maybe consider it so directly. And furthermore, we kind of have a situation where we may want to do fancier things where we're talking about a time range, a specific time range, where like the current frame is not really what our time basis wants to be talking about, if that makes sense. So we have some more things to do. I'm going to leave it like this just temporarily, but afterwards we'll kind of look at that a little bit more in a little bit more detail. In fact, now that I think about it, we probably want to address this a little bit more directly, even at the start. Because like I said, what I kind of wanted to do originally was make it so it drills down kind of gradually. And so in order to make it so it drills down, what I would want to do is I would want to have the notion that I'm only looking at, say, things that are one level deep in the stack, or that are they're one level deep in the stack under something in particular. And that's actually not that hard to do, actually, with the way that we're doing things here. So it's actually pretty straightforward to make something like that. And I guess, like I said, I guess I don't have to do it just yet, but that is kind of what I would rather aim for. Now let's do it. Let's just do that. So in order to do that, what we'd want to do is see, okay, for this particular thing, I only want things that are going to be at the like quote unquote top level. But top level might be differently defined. And so I'll start by doing the simplest form of top level, which is actual top level, which is to say that I'm only going to record a debug block as taking up space on our chart, meaning as an actual space in the region, if the opening event, right, on the first open block, right, so this thing here, if that first open block doesn't have anyone above it. Yeah? So if we take a look at what that means, let's see here. So remember, we're keeping a list of these, and they have parents. So if the parent of the open block equals 0, then I know it's a top level function that's being called, right? If its parent was something, but that something didn't have a parent, I would know it was 2 functions deep. And so I'm going to do some things where we kind of like get a little progressively fancier there on how we do this. But for now, that would do it, right? So I think, if you'll excuse me for a second, I just have to quickly, I changed that to being called thread ID. So I need to change it here to be that. So we need to implement get debug thread. First free block should be off of debug state. It's just a typo. Yeah, okay. So that's all good. If debug block starting frame index equals frame index, that would be thread. So what I actually need here is our matching block, I guess. I would want to call it debug open block. Or open block. So this is our matching block. So what I want to say here is matching block. So I need to implement those 2 functions. The other thing I need to do is, once we actually find an ending for something, so we're here and we now know that we actually matched this thing. You know what I mean? We need to remove it. That block, this matching block structure is like sitting there, you know? And it needs to be yanked off of the stack so that we don't keep growing the stack ad infinitum. So we want to have the thread first open block equal matching block next, right, or parent, I should say, so that it pulls off, and thread first open block itself, we would want to put that onto the free stack. Like so. So yeah, so that's basically what we're talking about. Thread first open block next free is going to be equal to whatever was there before. And then we've popped it off, right? So we need to implement these guys because they're not going to implement themselves. And I'm not sure what we want to do about add region. And how we want that to work exactly. But get debug thread is pretty straightforward. So that's going to take a thread ID, and it's going to look to see if it can find it. So remember, we've got this concept of the debug thread, and we know that our debug state has, a list of those. So we can just loop over them really trivially and say that, starting from that thread, and while it's still equal to something, if we find a thread with this thread ID, then we know that was the thread we wanted. If we don't, so if we get down here and result has never been set to anything, then we know we need to make another one of these guys. And so in order to do that, again, we can just go ahead and grab that push array, and we can change it to a push struct. So now we've got a new one. And when we get the new one, again, we want to add it to that list so it'll be there. So we've got our first thread, our debug state, our first thread just needs to get singly chained on there. So now we're tracking that properly, and that's good. But we need to figure out some way to add region. We still have not done that. Yeah, in order to do that, we would need to figure out where we're going to put it. So here's debug frame region, result, return result. And for now, we can just do like the cheesy way. I haven't thought about really how we want these to be going. But for now, since we kind of are saying that they're all stored in something that looks like this, really all we would be doing is saying, assert that the current frame region count is less than however many of these regions we typically have, right? So if we do this, max regions per frame. And that's why I said there's just a lot of max-ish things in here, which seems a little unnecessary. And so that's why I was saying it might want to just kind of daisy chain these things so that we don't have to care about that. It's just a thought. It doesn't really matter which way we do it. It's debug code, so as long as it runs okay for us, we don't have to care. We never have to battle-proof it for an actual end user's machine. So at some level, you can just do whatever is expedient and it won't really matter. But we do want to make sure that it doesn't end up slowing our frame time down too much, because then we won't use it as much, and that's always bad. So we do want to make sure we're at least, somewhat conscientious of how this is going to work at some level. But anyway, so if we go ahead and just do the standard thing here, when we get back one of these regions, all of this stuff is going to get initialized, I assume. But so we'll just leave it as it is, and we'll go ahead and recompile that. So now we have everything implemented. The only thing that we don't do at the moment is our frame bar scale is still not set to anything in particular. In order to set that, I'm not sure what the smartest thing to do there would be. For the moment, I'm going to do something that's not terribly good for our visualization, but that will at least let us see what we want to see. And that is every time we see a frame marker, I'm going to look to see if there was a current frame. You can see how we do it here, and we get the end clock so that every frame has the beginning and end clock. What I'd like to do is say, all right, if I take the begin clock and the end clock, then I kind of have a clock range. Does that make sense? So this is like the total amount of time that's taking up. And so the frame bar scale, if I wanted to map that into a range from 0 to 1, I would just do 1.0 over the clock range. So I'll just say, assuming that the clock range is greater than 0, so that there was some time taken by the frame, we'll set it up like that. Okay, so I've got about 10 minutes left on the clock, because we started a little late today. So I would like to go ahead and see if I can get this working, something which I did not do off the bat. Looks like I did a kind of a dumb thing here with the debug thread collation, which is fine. It's fine. Don't worry about it. So let's see. What did I do? Did I accidentally loop a thread back on itself? I did. Or, well, so that's not what happened. I just never initialized the thread ID. So yeah, that's a bit of a mistake. I admit that. Okay, it's true. Obviously, if you're going to try to look these things up, you kind of gotta actually set the values to something. You can't just let them be their default values or 0, because they actually need to match. So yeah, we need to set that ID properly. We want to probably set the first open block to 0, which we didn't do. So we just kind of were asleep at the switcher. We didn't do any of the stuff that we actually need to do on startup. The lane index is just, I think, going to probably be frame bar lane count. So debug state frame bar lane count will just increment that so that each thread gets the successive lane index. And that's fine. So let's see here. How many regions there were. Ooh, I want successful sales. How many regions were there? 64 regions. That seems... So I think we've got another bug here. I guess it's been a sleepy day, so I wouldn't be surprised we have a bunch of bugs. Seems pretty fair. But I feel like there shouldn't be that many regions at the top level of any given frame, and the reason for that is because we're only looking at just the top level. So how many things can open and close just at the top level, I don't know if it's going to be that many. Now, I could be wrong about that because I guess that could include sort of the other threads which are not really inside anything else. So maybe ones that do like open and close more often maybe could, I don't know. It seems unlikely. I'm a little bit wary of this, but I'm gonna let it ride just for a second, just so we can get a little bit more reconnaissance on where we are at. But it doesn't fill me with a warm, sort of fuzzy, glowy, happy, bouncy feeling, if that makes sense. So let's take a look. Max regions per frame. If I was to set that up to something high, what would happen? So it actually does work incredibly, incredibly slowly, I would point out. So we're taking a ton of time in the debug, because this, if you turn the debug off, runs in real time. And you can see kind of how slow it is already. But we are actually running, so that's interesting to some degree. So what we want to do now is we want to see if we can get these things working properly. In order to do that, I'm going to have to step in and see where we're at for how the collation goes. So I'm going to try stepping in here and seeing what happens. So when we actually start up frame things, I want to see, let's start by just seeing what the frame bar scale is, because that'll give us a little bit. Oh, well, you know what? That was kind of a dumb thing that I did, now that I think about it too. So one of the stupid things one of the things I was thinking is I was meant to keep whatever the largest one of this was, whatever the largest clock range was, and I did not do that. That was kind of dumb, and so I'm going to go ahead and assume something more like this here, where we just go, okay, This will be the frame bar scale, and I'm only going to keep it. I'm going to say if the frame bar scale, right, if this guy here is greater than this, then I'll keep it. So I'll allow it to get kind of, progressively wider if it wants to. That's what I meant to do. Otherwise, what it's going to do is just take the last frame's time and make it be that. And so just wanted to fix that while it was still in there. Again, not really probably what we want to do at the end of things, but we'll do it that way for now. Okay, so I'm just want to see what our frame bar scale ends up being at the end of all of this. So I'm going to go ahead and set it to here. I'll just step out. And then I'm going to take a look at I'm just going to inspect some of these values so I can get a little bit of a feel for what's going on. So the frame bar scale, I'm going to look at what 1 over the frame bar scale is, which will give me some notion of what its size is. So that's about 47 million. That's a totally reasonable value, because remember, these RDTSCs are in clocks. So that seems okay. I'm okay with that value. And so if we take a look at the frames themselves, if I see how many, okay, so there's 62 regions, there's 2 what look like fairly reasonable begin and end clock times. Here are the regions themselves. There's 62 of them. Here's lane index 0. It goes from here to here. Again, that seems okay. That doesn't seem ridiculous. So it doesn't look like we're computing anything ridiculous right now. So let's go ahead and take a look at the drawing of this when we actually go to draw it, so I can see, because we're not seeing anything right now. So we don't have any tested drawing code for it either. So it could just be that I did something stupid here or wasn't really thinking through how it goes or how it should go. So let's take a look. Here we are at our first region that we're going to draw. So I'm going to go ahead and look at what it includes. Here's the min t, here's the max t. Again, our frame bar scale. Debug state. Oh, well, I already pulled it out into scale. So there we go. So let's take a look at 1.0f over scale. That seems wrong. That doesn't seem like what I saw before. Right? It was a much more reasonable value when I looked at it just moments ago. So where is that coming from? I would like to know. I say. So it must have just only been the first frame that it was sensible? I suppose it's also possible that since we're in the debug timing code, it would be different. You know what else is true? We don't... Well, no, that's not true either. So I want to take a closer look at that, but in the interest of focusing on other things first, I'm going to set this to a hard-coded value so that I know that it will not be part of the issue, if you will. So I'm just going to assume something like 50 million. Right? I'm going to assume something like 50 million per frame, 50 million cycles. Because if you think about how many cycles there might be, if you're doing, say, 30 frames a second, and you're on a 2 gigahertz machine or something like that, that's going to be that, right? Which is, 60 million or something like this. So that seems totally fine as a value. So I'm going to set it to that so that we just have some known base and we can take it out. And then we can worry about calculating our scale a little bit later. So let's break that. All right. So the question is, why aren't we getting some more reasonable values? You can actually see that there were some values there, but they were little blips. So let's go ahead and take a look. Again, let's sort of step into that. Well, we're just about out of time, so I'm just going to step through this one time with the drawing so I can take a look at what it's actually doing, and then we'll pick this up tomorrow. Okay, so here we are with our first region. We have a region index, which is just which number it is. We grab out whatever color is happening there. Should probably get the colors in a better way too, but and so that's fine. We take a look at what the this min y and this max y are, and they're relatively same values. The only problem is the clock values are small enough that they don't span any actual space, right? And then we draw them. So the question is, are all of our values coming out that way? So let's take a look as we come through the next time. Yeah, so these just don't take up very much time at all, right? So I don't know if that just means I'm being overzealous with the amount of cycles, but it should be counting the entire outside cycles, which means it should have been somewhat close to that value that I was suggesting there. But it clearly isn't. So I'm not sure why. We'll have to take a look and find out. Yeah. So we're almost at the end of the regions. So yeah, I don't know why we are so far off there. That doesn't really make a whole lot of sense to me, because I feel like this scale should be roughly correct. If that makes sense. I also don't know why there's so many of those, so that also suggests that we probably have a bug in there as well, because there shouldn't probably be 64 different things open and closing. That doesn't really, on a single frame. I don't know. Doesn't seem that likely. I guess across all the threads, maybe that's plausible. Across all the threads, maybe. But it doesn't sound right. So if we take a look here, opening clock minus begin clock, event clock minus begin clock, that looks like the right values to me still. And so the only thing that I don't know about is the frame bar scale incorrect? And I don't know. Oh, well, it occurs to me, though, that we don't ever multiply by the height here. So our scale factor is actually missing this value. So maybe it's actually fine, right? Because it needs to divide by the bar scale and then multiply out to the chart height. So actually, that could have just been largely chalked up to that bug, which does seem like an oversight. However, let's go ahead and we go through here. There we go. So yeah, looking at this, we still are getting fairly nonsensical results out of this, though, because we should be seeing a bar for every frame, and we're totally not seeing that, right? Like this is clearly not making any sense in terms of the individual frames themselves. Yeah. So I'm going to leave that because, like I said, we're out of time. I'm going to go to the Q&A, and I believe tomorrow it should be relatively trivial for us to just debug that part and get it up into good shape, which would be nice because I think that's mostly it for getting something good on the screen. And then we can just start focusing on how we want to, like, you know, be able to pick from the data and like switch between a couple different ways of viewing it so that we can see what's going on and that sort of stuff, which I think will be nice. All right, so that's pretty good, assuming we can do it tomorrow. I'm going to go ahead and go to the Q&A and see if people have questions. If you have a question about what we are doing, please put Q: in front of it so that I can see it. Insofar as, is there going to be debug visualization of the asset memory chunks? Yeah, I would like to do the same thing for memory as we're doing for time, so that we can see not necessarily just the memory asset memory chunks, but also the other memory chunks as well. Zendash, can you make a mini episode about project management, outsourcing, freelance hiring, programming is great, but making a game takes more. If not, can you point to good resources on the topic? That's not my expertise. That you'd have to ask someone who does that sort of thing for a living. Do you use the same memory model as in Handmade Hero when writing utilities or meta programs, or do you just malloc and it wouldn't matter because the thing runs once, does its thing, and closes? So when you're metaprogramming, you basically... So the point of metaprogramming is to get all the benefits that you normally get from going to sort of like a bloated, crappy thing, like templates or something, without the bloated crappiness. So actually what you do in metaprogramming is you just have all of the stuff that you want for memory allocation and data structures. So like, you know, do you want AVL tree? Do you want hash table? Do you want a arena allocator? Do you want reference counted allocator? I mean, heck, if you want garbage collection. Whatever you want, you can implement those systems. And then since you're metaprogramming, it's free for you to just basically wave a magic wand and say, bonk, this section works like this. And the meta code just generates that thing for you. Because that is the right way to program, in my opinion. You know, my objection to C++ programming with templates and stuff like that is that templates are fundamentally a bad metaprogramming system. It's not that you don't want to be able to just write a linked list once and then use it. That's exactly what you want to do in programming. The problem is C++ doesn't give you any way to do it because it's so lousy as a language, right? So when you say like what kind of memory management you use when you're metaprogramming, well, you pick whatever is appropriate for the job, and it's a lot easier than what I'm doing here where I have to hand code things because once you do it on a meta scale, you don't have to worry about how expensive it is to implement. You only have to worry about how expensive it is to run, and you can pick the thing that is the least expensive to run in that case that does the thing that you want. And that's fundamentally how programming should but does not work because we don't have good languages. Culverfly, what are the pros and cons of viewing debug information real time versus logging them and viewing them after the fact? Speed is number one. As we've already seen, you know, it takes up a significant amount of the frame time potentially to run through all this debug information because we're dumping lots and lots of debug events at the moment, and you want to be able to dump a lot of them. So speed is one. For lack of a better term, accessibility on the developer's workstation. I'm not sure how else to put it, but a typical situation in professional game development is that I may not be running the game on the same machine that I'm like actively developing on. So the example would be like if I'm going to develop this game for PlayStation 4. So you're doing like Handmade Hero PlayStation 4. Well, the PlayStation 4 dev kit thing may not have like a mouse and keyboard hooked up to it or any way of interacting with it in a good way, right? And so if you have a way of just sending all of those debug events over the network so that they can come off of the target platform and onto your dev machine, where you can then view them in a nice little application that isn't, some kind of janky thing you have to use a gamepad to view, right? That's really nice. And so we don't have that situation in Handmade Hero, but you could understand how in a professional game development setting, you may be in a situation where that was true. So that's the second thing. The third thing is historical analysis. So if we're just keeping the things in memory and we're not dumping them out to disk, this isn't so much a benefit or a drawback to doing it real time. It's more like, why might you want to dump them to disk? Even if you did, even if you still are viewing them real time, you might want to dump them to disk because then you can look, if you have a particular run of the program that you think is weird, but you're not sure, you could maybe look and compare it to another run and go, was this thing that I'm seeing, is it really that unusual, or maybe it was in previous runs? Like, how long has this been happening? How long do these things typically take? That sort of stuff. So historical analysis, either across a long run of the same, across a long timeline for the same run, or across multiple timelines for multiple revisions of the program, are both reasons you may want that historical data. Those are probably not, none of those are probably super compelling reasons for us to do it on Handmade Hero, because we probably won't need much of that. But you could see, again, in a professional game development setting, sometimes you have circumstances that are going to be different that can warrant wanting these things, like developing it for a console, like having playtest data that's happening remotely, right? Things that we're probably not going to encounter on Handmade Hero, which mean that we would not get very much value potentially out of implementing something like that, versus the time it would take us to implement it. So on Handmade Hero, it might be a bad decision to go make that. Or if you're making an indie game, it might be a bad decision for you to do that. If you're talking about a game development scenario where you're on a team of 50 people and there's a QA department and God knows what else is going on, sometimes these things then become valuable to do because of these other circumstances that aren't similar. Abner Combre, people want you to actually drink chocolate wine sometime. Are you up for it? Yeah, I mean, I'm going to drink chocolate wine at some time, but I can't promise that I'm going to actually even drink a glass of it. I mean, I may drink like a smallest, tiniest sip and go, that was absolutely disgusting. Because remember, I think wine is awful. So it's possible that I'll drink chocolate wine and decide that chocolate wine is actually good, but it's also possible that I'll think chocolate wine tastes too much like regular wine, which I don't like. Are you going to Indiecade in Culver City? No. Would you recommend it? I don't know. I've never been. Elvin, thanks for mentioning CMIR. Addresses a lot of my issues directly and is much more human readable. What was the get token written for config files? Doesn't seem like for C code. Yeah, it's for config files. So it's for stuff that's like foo equals, number semicolon. Foo equals string, comma, another string, comma, number, semicolon, right? So like little expressions, but no functions or things like that. How will you debug the OpenGL Direct 3D stuff when you will ship? So are you talking about, so we don't use any OpenGL Direct 3D at the moment. Are you talking about once we write OpenGL Direct 3D stuff? The answer to how we debug it is, the same way you debug anything on a GPU is like ad hoc, man. Debugging on GPUs is awful. It's one of the reasons I really don't like GPUs. I wish we didn't have them. It's just the case that you have to do a lot of malarkey. Sometimes you can use some tools that sometimes work. There was Pix, there's Nsight debugger, and there was Gremity's thing, and there's the GL trace that Valve made for Linux. There's tools you can use that may help you, but a lot of times the way I do it is just old-fashioned, test, set some things, test to see I know that I should see this. If this happens, I don't see that. Okay, so I know that this isn't working. It's just, a lot of times debugging GPU code is really annoying because you can't step into it. And I don't like that. I think it's lousy. I complain about GPUs all the time, and I mean it. I think they're a bad thing for programming. They're sloppy. They don't have an ISA. They don't have real debugging. They're just a bad thing for programming. They're not. CPUs are good and GPUs are bad generally. And so, I hope that maybe someday that gets rectified and things are more like a CPU that have proper debugging support. And like I said, sometimes you can get a tool depending on your platform, depending on what card you have, depending on, you may be able to get some tools that you can use that are shipped by either the vendor or some third party, which will allow you to get some semblance of debugging, maybe not like actually stepping through things, but some semblance of debugging for your GPU. And sometimes you won't have that, and you just have to roll up your sleeves and do it the old-fashioned way. David Thomas 426. Did I misunderstand Molly Rocket.com, or should there be a comic today having something to do with your project? Oh man, so you actually, I didn't know anyone was actually going to Molly Rocket. There is there is a test thing up there. I didn't know anyone went to it yet. There is a test page up there, but actually it'll probably be this coming Monday that the updates will start. This was only for testing. I didn't know anyone went to mollyrocket.com. Sorry. But yes, you interpreted it roughly correctly. Actually, the first announcements will actually be about Handmade Hero. But then there will be information about our project. So yes, starting this coming Monday, I'm still ironing out CSS issues. This is also not actually quite what the site looks like yet. Like I said, it's a test page. The site is a little more designed now and has some navigation and stuff in it. So I was kind of working that stuff out. So this coming Monday will be the first post, and then every Monday thereafter there'll be a new post with information on stuff that we're doing. Let me see if there are any more topics about what we were looking on. Okay, so I don't see any other questions that are specifically about what we were doing. So since we're roughly out of time, I'm going to go ahead and wrap up here. It looks like, is there anything else? Just, yeah. Okay. So yeah, anyway, if you do want, sorry, again, like I said, I didn't realize that anyone looks at this page yet. I was going to announce it as soon as we had the website design done. We have the content ready for it, so we could have actually posted the thing today and started our updates today, but web development being what it is, I'm still not really done with all of the stuff that's necessary for, like, the CSS awesomeness and all that stuff. But yeah, we'll start the updates, and like I said, the first one, possibly two, will actually be about Handmade Hero, because there's some announcements I have to make about that have kind of been backed up because we didn't have a website. And then we'll start a little article series about the game we're doing at Molly Rocket that'll kind of like lead up to an announcement of that as well. So yeah. All right, but that said, let me go ahead and wind down the stream here. Save this guy. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along at home with the source code, you always can pre-order the actual game, and it comes with the source code. If you want to kind of like do your own experiments with it and learn from it and stuff like that, you could do that. And I update the source code every night, so you can always stay up to date with whatever I'm doing. We also have a Patreon page. If you just want to support the video series, you can subscribe to that. We have a forum site you can go to if you want to ask questions or like look at an annotated episode guide that people have put together that's pretty cool, that kind of stuff. It's all up there. I highly recommend checking it out. We also have a tweet bot that tweets the schedule at you. So if you want to know when the stream's going to be live, you want to catch it live, that's the place to go for that. I will be back here tomorrow, 5 p.m. Pacific Daylight Time, where we will play around with our charts and kind of get the charts working. I think we pretty much did all the work that needs to happen today, so I think we're just basically down to debugging. And then from there, we can sort of start to build a little bit of a UI on there, so we can kind of like have a way to, you know, click through things and inspect things, hover over something and see what function it is that's taking the time, that sort of stuff. So we'll give that a shot and play around with the vizzes a little bit. That's about it. So until then, I hope that everyone has, oops, that was supposed to be closed. Until then, I hope everyone has fun programming, and I'll see you guys on the internet. Take it easy, everyone.